Okay, hello guys, back again. Going over a few more section 14 problems. Don't know who requested these because whoever it is doesn't have their name set up on their remind, but this is page 348, the beat the test problem. Janitors at Strickland High School empty 25 full trash cans every day. The design of each trash can is shown below. Based on the information and diagram above, what is the total volume of trash that the janitors empty each day? So, these trash cans are made up of two separate pieces. We've got a rectangular prism, and then we've got a semicircular prism. So the rectangular prism is the easy part, because the rectangular prism is just going to be, the volume is going to be length times width times height. And that's going to be, doesn't matter which of these is which, 3 times 2 times 4.5, which is 27 cubic feet. Okay, easy peasy. The semicircular prism, that is the base of each, the bases of the prism are going to be those semicircles. So the volume of any prism is always the area of the base times the height. So we need to find the area of the semicircles, and then we need to multiply that by the height. The height is the distance from base to base. And that distance is going to be 3 feet long. It didn't matter with the rectangular prism which distance was which, but it very much matters in the semicircular prism or any other type of prism that you have other than rectangular. So the area of the semicircle, well, the area of a circle is pi r squared. The area of a semicircle is going to be 1/2 pi r squared. And this distance right here is 2 feet, which means that the radius is going to be 1 foot. So the area of those semicircles is going to be, of that semicircle is going to be 1/2 pi. So we've got the volume is 1/2 pi times 3. This is the base, and this is the height. So the volume is 3 pi over 2, or approximately, using 3.14 for pi, even though I, of course, don't like to do that, but geometry, the EOC probably does, 9.42 cubic feet. So the total volume of each trash can is going to be 27 plus 9.42, which is going to be 36.42 cubic feet. But then, that's not all, because there are 25 of them. So, we have 25 times 36.42 is going to be 910.5 cubic feet of trash. And they do not specify where to round to, so I ended up using the decimal using the 3.14 decimal approximation, getting 910.5 exactly. If I were to have used the pi button, whoops. If I were to have used the pi button, I would have gotten 910.62. I hope, and remember, I have not seen this test. I'm not allowed to see this test. I hope that they tell you whether to use tell you to use 3.14 or to use the pi button on the calculator, because I'm pretty sure you do have a pi button. I don't know whether they're going to specify or not. So use your best judgment. All right, the second question we're going to go over is this try it problem. Describe the shape of the cross section of each of the following objects. So we have a right circular cone cut by a plane through the vertex and perpendicular to the base. So you guys are going to see my terrible drawing abilities, and drawing on the iPad is even harder. So we've got a right circular cone that looks like that. We are cutting this with a plane that is through the vertex and perpendicular to the base. Okay? So, you have to think about what this would look like when we cut it open. And really, there's no good way to explain it unless we could actually do it with the three-dimensional objects, which would be fantastic. Any of y'all that have any little kids in your house, if they have Play-Doh, go grab some Play-Doh, make some three-dimensional objects, and cut them with dental floss. That's going to be your best way to envision this. But this is going to end up creating an isosceles triangle. Well, that's not writing. All right? Because if you think about just cutting it in half vertically, the thing that we see when it's cut in half vertically is a flat surface. It's got a point up at this vertex, and then its sides are the sides of the cone. So I hope that makes sense. It's really, really hard to represent a 3D object two-dimensionally. Okay. A square pyramid cut by a vertical plane that is parallel to an edge of the base and does not pass through the vertex. So, again, my terrible drawing. All right. So we're cutting this perpendicular to the base. We're not having it go through the vertex. We're cutting off a side. That's actually like the opposite of helpful. Okay? So, let's visualize what's happening when we're cutting this off. All right? We're cutting off. Okay, maybe this will help. We're cutting off like this side of the triangle. We're cutting off like here. We're cutting off like here. We're cutting off like here. But the thing is, what I just drew makes it look kind of like a rectangle, right? But are these back and front faces of the pyramid, are they perpendicular to the base? No, they are not. So we have a four-sided figure that's got one pair of parallel sides. That figure is a trapezoid. And it's actually going to be an isosceles trapezoid. Since this is a square pyramid, everything is centered. So it is going to be isosceles, or at least it should be. All right. Describe the radius of the circular cross-section created by a plane through the center of the sphere with radius r. Okay. So if we've got the sphere, or the sphere has radius r, and if we cut it right directly in half with the plane, then we are creating two hemispheres. Won't those hemispheres have the same radius as the original sphere? Sure. And won't the cross section just be like the side of the hemisphere that was cut? Yes, it will. And that will end up giving us a circle that has the same radius as the sphere. Okay? All right. So then last, if we rotate the following polygons around a given line, what solid would we produce? A semicircle rotated around its diameter produces a blank. All right, so we're visualizing this going around in a circle, winding up right back where it started. I hope that you can see that all of these rotations are going to produce a shape that is round. There are not going to be any vertices created by these rotations. So this semicircle that is rotated around its diameter, that's going to produce a sphere. Because you've got a rounded thing being rotated around, that's giving us a sphere. All right, a right triangle rotated about one of its legs. Well, think about sort of how we measure the various aspects of this shape as we rotate it around. The bottom is creating a circle. The top is staying fixed in place. This side is going to remain slanted. This is giving us a cone. And lastly, a rectangle rotated about its edge produces what? So we're rotating around the edge. Again, this is giving us a circle. This is giving us a circle. This side right here is staying perpendicular to those circles that are being created. So this is producing a cylinder. All right, I hope that was helpful. I will post this, and remember, continue to send in your questions, and I will talk to you guys tomorrow.